Right, good to see you again. I'm sorry for being inactive recently. I've been super busy, haven't had the time for making videos. That's about to change, however. Let me introduce you to my new project, a 3-axis CNC mill. I'll be honest, this isn't exactly a new project. It started earlier this year with the idea of making a CNC milling machine myself. After starting this project, I worked on it one step at a time whenever I've had extra time for it. I didn't want to film the whole manufacturing process because I knew it would be completed over such a long period of time. What I wanted to do instead was to complete the assembly and then go over the design and manufacturing briefly, and this is where we are right now. Now, what I'm planning on doing in the near future are things such as installing all the limit switches, getting the cable chain set up, getting the spindle running, then I'm going to go configure Mach 4, get the machine running, After that, it will be time to take the first chips, then start learning Fusion 360 cam and the secrets of machining. Now, what my plan is to make videos of the bigger steps that I just mentioned, and then possibly make a bunch of shorter videos along the way of some interesting topics regarding the machine. But now, let's start with the future and jump back to this moment. It's time to go into Fusion 360 and take a look at the design. So here on the screen lies a pretty typical 3-axis milling machine. It has linear rails and ball screws on each axis. I picked up 3 sets of rails and screws from eBay and they turned out to be okay quality. These are HGR20 rails with corresponding sleds and the ball screws are SFU 1605s. Each axis is run by a 3Nm NEMA 24 closed loop stepper. I bought 3 identical sets from Stepper Online, each containing a motor and a driver. 3Nm was plenty of torque, and these steppers being closed loop gave me extra accuracy and redundancy on the control loop. The machine is designed around a frame built from 60 by 40mm steel beams. The frame is welded together and 2 spacers are welded on top of the frame. These spacers act as mounting surface for the Y-axis linear rails as well as the whole Z-axis assembly. All the mounting surfaces were machined flat after welding to ensure decent straightness and parallelism. This also ensures that the Z-axis assembly has a flat and straight area to attach to. The Y-axis has 2 400mm rails that are bolted to the spacers. Ball screw mounts and motor mount are all welded to the frame and the ball nut moves in between the mounts. Now this machine has a connector plate connecting the Y and the X-axis. This plate moves along the Y-axis and the X-axis assembly moves on top of the plate. The X-axis assembly is constructed from a T-slot table that has similar spacers mounted on the bottom. X-axis has 500mm linear rails that are attached to the spacers. Slide blocks and the ball screw mount for X-axis stay stationary on the connector plate. This way, the X-axis assembly drives itself left and right relative to the connector plate. The top frame consisting of the Z-axis is constructed from 150 by 150mm steel tube that is welded to a flat steel plate. This plate has holes for bolts that allow the top frame assembly to be bolted to the bottom frame. This allows the machine to be easily separated into 2 pieces if ever needed. On the steel tube there are once again 2 spacers with 400mm rails. These rails allow the spindle carriage to move up and down. The spindle carriage itself is welded together from steel plate and has correct mounting holes for the slide blocks and ball nut as well as the spindle mount. Now, this milling machine assembly sits on top of a carriage that also houses the electrical cabinet and a computer running Mach 4. Carriage has a monitor arm that's got space for a keyboard and a mouse. This arm can be moved and rotated to allow for better storage and ergonomics. I'm also planning on adding a cover around the machine to make it safer and stop the chips flying around and making a mess. What you currently see on the screen is pretty much where we are right now in the real world. The Y and the X axis have been built, assembled and tested. The Z axis still needs some tweaks and then it can be assembled and added to the machine. After having all the axes in the machine running, I'm going to add all the peripherals such as limit switches, cable chains and the water cooling lines for the spindle. I think that'll be the topic of the next video. But for now, thank you for hopping on board this project and a big thank you to all the subscribers. I recently broke the 500 limit and it's great to see people are interested in the content I make. From here on, I will also be posting more actively, especially with this project. Thank you guys for watching, and see you on the next one. Cheers.